IBESS, Soil and Terrestrial Food Production, Part 5, will examine soil management strategies. Now, this is the second and the last of two movies that examine soil conservation strategies. The significant ideas are human activities may reduce soil fertility and increase soil erosion. And secondly, soil conservation strategies exist, and they may be used to preserve soil fertility and reduce soil erosion. Here is the first of two slides that outline the available movies in the Soil and Terrestrial Food Production Unit. Use this outline to find the movie you need for review. This movie is focused here. Here's the second of two slides that outline the available movies in the Soil and Terrestrial Food Production Unit. Use this outline to find the movie you need for review. Here are the two IB syllabus statements that drive this movie, and this is the second time you're seeing these statements, as I had them both embedded in Part 4. Outline soil conservation measures, including cultivation techniques, terracing, contour plowing, strip cultivation, wind reduction techniques, windbreaks, shelter belts, and soil conditioners, organic and lime, and avoiding the use of marginal land. Evaluate soil management strategies in a named commercial farming system and in a named subsistence farming system. Here is a list of soil conservation measures. In the last movie, we looked at terracing, contour plowing, windbreaks, and soil conditioners. And in this movie, we will examine the measure of avoiding the use of marginal land. And then there are some important measures, not specifically mentioned in the IB syllabus, but they remain very important, and I'm going to cover them here. These are till techniques, cover crops, crop rotation, and reforestation. I will work to evaluate each technique, providing both strengths and weaknesses. And with each image I present, I want you to evaluate whether the soil conservation measure better serves a commercial farming system or a subsistence farming system. Some land is perfectly suited to be used in agriculture, as you can see on the left, while other land on the right is more marginal. The marginal land might be steeply sloped or just too dry to farm. As the world's population grows, or as farmland becomes degraded, people are pushed to use marginal land. To better conserve soils, we need to avoid the use of marginal land. The photos here display marginal land, and yet you can see that people have been pushed to farm these lands. If we can avoid the use of marginal land, erosion is reduced, desertification is reduced. Avoiding the use of marginal land has big benefits: less soil erosion, less desertification, and marginal lands, if left alone, might provide ecological services. But there are weaknesses if we avoid using marginal land, and that would be that local societies may not have enough food, as no other land is available. Here are the strengths and weaknesses of avoiding the use of marginal land. Take some notes. I'll let you study this slide on your own. Here's the outline I'm following, so let's continue with our examination of soil conservation techniques by looking at till techniques, plowing techniques as a mechanism to conserve soil. If the soil is tilled less, plowed less, or the remains of last year's crop is left on top of the field rather than being removed, soil erosion will be reduced. Reduced plowing and leaving last year's stubble on the field are together called conservation tillage. Ridge till is a similar technique that involves pushing the soil into ridges that serve to receive the seed as the field is plowed. Ridge till, like any conservation till technique, involves plowing less and leaving parts of last year's crop on the field. Conservation tillage. Erosion is reduced because the land is less disturbed, less exposed to wind. Can you evaluate conservation tillage? Get ready to take some notes. The strengths of conservation till techniques are more than meets the eye. There's a reduction of wind and water erosion, a reduction of fossil fuel use due to less plowing, and the soils hold water more effectively. But the weaknesses are there's the possibility of more pests due to increased organic matter in the soil, and more pests may require more pesticide. Now keep in mind that subsistence farm systems have historically practiced conservation till techniques. However, more and more industrial farm systems are beginning to employ conservation tillage with success. The use of a cover crop is the third soil conservation technique of this movie. This technique employs the use of another plant species, often a pea family plant, grown not so much to provide natural income but to reduce erosion and improve soil fertility. Plants in the pea family have a mutualistic relationship with soil bacteria that fix nitrogen. Using pea family plants as a cover crop enhances soil nitrogen and reduces erosion. Here are images of cover crops, pea family plants, on the field, and this is instead of having the field be fallow, be empty with exposed soil. Using a cover crop serves to reduce erosion. It encourages nitrogen fixation through the use of the pea family plant, and cover crops add organic matter to the soil because the plants are turned into the soil at the end of the season. Here is a nice photograph of a cover crop. One disadvantage for the farmer is that there's less productivity in the short term. Instead of growing a marketable crop, the land is given a chance to recover. But the land is not fallow, so erosion is significantly reduced. Can you evaluate using cover crops as a soil conservation technique? The strengths of cover crops as a soil conservation technique are reduced soil erosion, building soil by adding organic material. Pea family plants can be used to fix nitrogen. The pea plants have a mutualistic relationship with bacteria, rhizobium bacteria, that add nitrogen to the soil. And lastly, cover crops gives the soil time to replenish its nutrients. Weaknesses? It's costly. Planting a crop from which no income will be generated costs the farmer money and time because some money will have been spent to plant the cover crop. Crop rotation is the fourth soil conservation measure of this movie. Crop rotation involves planting different crops in a field over time. The idea is to change the crop every season in a single field instead of planting the same crop season in, season out. In one field, plant a legume one season, a leaf crop the next season, a fruit crop in the third season, and a root crop in the fourth season. This technique reduces the exhaustion of nutrients experienced by fields that are repeatedly planted with the same crop. Changing the type of crop grown in a field over time allows the farmer to include a pea family plant for the mutualistic relationship that pea family plants have with nitrogen-fixing bacteria. This adds nitrogen to the soil. Including a pea family plant in the rotation enhances soil nitrogen without having to spread extra fertilizers. Here are the strengths and weaknesses of crop rotation. The strengths are that the soil retains certain nutrients from each crop planted, and the soil is not depleted of all of one nutrient. A second advantage is that nitrogen can be added when using a pea family plant in the rotation. Weakness? Well, the crops planted might not always be fetching the best price, so there's lost income. So in this movie, I've been following this outline, and we've been looking at avoiding the use of marginal land. We've looked at till techniques, conservation tillage. We've looked at cover crops and cover rotation, all as measures serving to conserve soil. Lastly, reforestation, allowing the land to grow back after repeated disturbances, and actively replanting species. Here is a photograph of volunteers working to plant trees on a hillside in an effort to reforest an agricultural area in Eastern Asia. Reforestation serves to bring back all of the advantages of ecosystem services that intact ecosystems can provide. Here is a photograph of a reforestation project. You can see the young trees that have been planted here. The reforested area is protected from grazing cattle and any further disturbances. This is a photograph of a program to revegetate a sand dune system in Iran. Presumably the area had been highly disturbed, probably by grazing animals, and now there is an attempt to slow erosion by allowing native plants to return. Here is a photograph I took of reforested areas in New Zealand. You can see the purposeful rows of trees of different ages planted on this hillside. The forests here are seen as natural capital, producing natural income as timber, wood. Locations are deforested and then reforested in a cycle. This is another photograph from New Zealand. You can see various land use patterns in the photograph, from native forest on the distant hillsides, apparently not having been cut yet, to deforested areas to reforested areas, and in the valley bottom, where deep soil accumulated over long periods of time, a farm for growing food crops. It appears that there is a harvestable crop on the right, while the field on the left has a cover crop, allowing the field to rest while enhancing soil nitrogen with a pea family plant. The strengths of reforestation projects are reduced erosion, increase in water retention, an increase in flood control. Forests provide many ecological services with the possibility of natural income from a timber crop. The weaknesses of reforestation projects are that there is potentially lost income, nothing more. Reforestation is important as a goal in all societies, but population growth is putting pressure on all of nature's resources. Unfortunately, in the balance of deforestation and reforestation, the rate of deforestation in the world is higher. Here is an IB syllabus statement that I've been following. Evaluate soil management strategies in a named commercial farming system and in a named subsistence farming system. And here is an IB syllabus statement that foreshadows our future. Commercial, industrialized food production systems generally tend to reduce soil fertility more than small-scale subsistence farming methods. Throughout the discussion of soil conservation measures, I've made reference to industrial farm systems and subsistence farm systems. Let me bring this movie to a close with a brief look at each. Subsistence farming is farming with the intent of feeding a family, not generating an income. Subsistence farming is farming without producing extra that would be sold in the market. Subsistence farms generally have low inputs and low outputs. Subsistence farms are generally more diverse, often a polyculture, and subsistence farms employ many soil conservation measures that tend to reduce soil degradation. Subsistence farms are more sustainable than industrial farms. The industrial farm is large-scale agriculture, high inputs and high outputs for the purposes of turning a profit. Industrial farms are often monoculture farms, low diversity. Industrial farms experience more environmental degradation than subsistence farms. Thus, industrial farms are considered to be less sustainable. Commercial industrial food production systems generally tend to reduce soil fertility more than small-scale subsistence farming methods. I would expect you to be able to explain this statement. With terracing, windbreaks, manure, low tillage, and crop rotation, subsistence farm systems degrade soil fertility less than industrial farm systems. And one last farm system of which you should be aware, it's called slash and burn. Slash and burn farm systems are a method of agriculture used in the tropics in which forest vegetation is cut and burned, the land is cropped for a few years before the people leave the area for another area, only to repeat the process. In this way, the land is exploited and then left to recover. The strengths of slash and burn agriculture are the land is left alone for periods of time, so the soil is given time to recover. Some organic matter is left on the soil, and the burning of vegetation does provide a quick infusion of nutrients to the soil that increase the growth of crops, increase the NPP, at least in the short term. The weaknesses of slash and burn agriculture are if the land is not left alone for long enough time before families return, the soil becomes depleted of nutrients. If the farmers farm the plot for too many years in a row, the soil becomes depleted of nutrients. Burning the vegetation reduces the amount of organic matter that could be added to the soil, and this would reduce the water holding capacity of the soil. And that brings us to the end of soil and terrestrial food production Part 5.